In this video, I would like to present PARTNR, Pick and Place Ambiguity Resolving by Trustworthy Interactive Learning. First of all, I would like to explain the motivation for this work. Recently, we've seen amazing advances in natural language processing, and these have also found their way to language-conditioned imitation learning methods. However, they often lack trustworthiness, and especially in the case of language commands, this can be a problem since language can be ambiguous. Therefore, we would like to identify ambiguities and train these methods in an interactive fashion. And in this way, we can reduce the number of required demonstrations, improve the system's trustworthiness, and we can adapt to changing environments and learn how to recover from failure states. We formalize the problem in the same fashion as transporter networks, since we're also considering tabletop efficient-based manipulation problems. We're trying to find a mapping from observations to actions. Using imitation learning, we can estimate value functions, pixel-wise value functions for both picking and placing, and collect data sets of human expert demonstrations. We would like that when there's an action ambiguity, no single distinct maximum, that the robot hands over control to the human and learns from additional demonstrations. In PARTNR, this works as follows. We observe the environment and obtain an image and a language command. From our model, we obtain pixel-wise value estimates for both picking and place success. And we can identify local maxima and use these to obtain ambiguity measure of the model's output. And in case the situation is ambiguous, we ask the human for an additional demonstration and train the aggregated data set. In practice, this works as follows. So here we have the language command, pick the yellow block and paste in the red bowl, and the top view image. From our model, we obtain pixel-wise value estimates, and normally one would take the action with the highest value estimate. But we identify multiple significant local maxima in order to get a measure of the ambiguity of the model. And we do this for both picking and placing. In our experiments, in this setting, we evaluated our interactive model against a non-interactive baseline, which was a variant of clipboard. Our experiments showed that with PARTNR, we can improve the performance, trustworthiness, and data efficiency of the non-interactive baseline. However, our method has the following limitations. In case of multiple valid choices, we query the human, which is not always desired. And also, we only demonstrated the effectiveness on short horizon tabletop manipulation tasks. So for future work, we would like to extend our method with an ensemble approach to further quantify uncertainty and extend to 6D poses and sequences of actions and evaluate this in a participant study.